Hi, my name is John and I'm a Unity developer. My objective in this video is going to be to give an update on the limb simulation that I've been working on. So this limb simulation is a kinematic solver. That means that it takes certain constraints on limb segments that we have in the simulation, and then it tries to train up a sequence of angular distensions on those limb segments that allows us to touch certain targets that we specify within the simulation. So for example, here we have 3 limb segments, and this limb is trying to touch this sequence of touch targets here in gray, in translucent gray. So for example, this limb sweeps from here and then all the way to there. And the same goes for all of these other limbs. We have another sweep, and another sweep. So the limb simulator achieves this by using a basic machine learning process, and it's basically just it forms a very small gradient at any point within the training process, and it tries to figure out what it can do in order to move closer to the solution specified. And the constraints that we have on these limb segments allow for slightly more biologically plausible solutions than you might otherwise get in inverse kinematics. Okay, and ultimately the objective here is to create a series of keyframes and then interpolate between them. And so you'll notice that in each of these limb simulations, in addition to there being a series of touch targets, there's this white line, and the white line in each of these simulations represents the computed force that we expect the limb simulation to produce. And so in the longer term, what I want to do is expand this limb simulation to incorporate whole body movement, and also to train not to touch certain touch points within a series of keyframes, but instead to just train in order to exert a force using a limb. And that'll give even more biologically plausible motion, and it'll also reduce the labor that is involved here. For now, though, I'm using a combination of both touch targets and trained forces. Okay, so let's look at these in more detail. So for example, here I had a basic attempt at a simulation of a human foot. So it extends forward and then takes a position on the ground and then pushes forward. And you'll see the resultative force that it exerts there. It's upward to counteract gravity, and also in the backward direction in order to propel the mover forward. Here was a rudimentary simulation of a bird wing that I produced. I don't know how birds fly, but the objective here was more to emphasize that there can be multiple segments that derive from another root node segment, or limb segment, sorry, in order to show that we can train for multiple objectives. And these last 2 movements are supposed to emphasize a critter's tail. Let's just look at this first one. So this is supposed to be sort of like a scorpion stinger moving forward, that sort of motion. And you'll see that it curls up and then it flicks over, which I don't know how stingers sting, but I think it looks cool. Okay, and then this one is more of a tail whip. You'll see that the tail starts from this position and then whips around like that and then comes forward. And note 2 things. First of all, that the force exerted is off, it's vectored off in that direction, whereas the force exerted by this stinger is substantially more forward. The other thing to take away from this is that in this tail whip, you'll notice that the tail builds up momentum as it arcs from here to here to here to here, whereas there's much less momentum able to be built up when performing a stinger move like this. And so that's represented in the difference in force distance that these limbs exert. So again, I'm going to be moving toward a whole body simulation, and it's going to train in order to exert forces rather than to meet certain touch target constraints. And I'll give another update when I get to that position.